Hello everybody, this is the last part of chapter 7. We've spent the whole chapter 7 dealing with just right triangles, Pythagorean theorem, special right triangles, the similar right triangles with the altitude drawn in there, and then the right triangle trigonometry, sine, cosine, and tangent. Those ones only work for right triangles. So, what happens when you don't have a right triangle? There's still a relationship between the angle measurements and those side lengths. Okay, that's what those trig ratios were. The sine of an angle in a right triangle was that ratio of the opposite over hypotenuse. Tangent was opposite over adjacent. All right, those trig functions related angle measurement to side lengths of a triangle, of a right triangle. There's still a relationship. If you don't have a right triangle, there's still a relationship between angle measurements and side lengths. It's just a different relationship. Okay, you cannot use sine, cosine, and tangent like you did with a right triangle if you don't have a right triangle. So there's two laws: law of sines, law of cosines. The first one we'll talk about is law of sines, and that'll be the first video. I'll do a second video for law of cosines. So to get the to get the law of sines, where it comes from, it really doesn't matter which. You're going to do the same thing a couple of times, and I'll just go through this really quick. If you draw in, we have just a generic triangle. It's not a right triangle, it's just a generic triangle. If you draw in an altitude from one of the vertices, and we'll call that H. Okay, what that's done is created two right triangles. So now, in right triangle 1, this one here on the left, if I did the sine of angle B, because I'm now, by drawing in that altitude, now I'm dealing with a right triangle. The sine of angle B would be the opposite side, which is H, the side we just drew in there, that altitude, over that right triangle's hypotenuse, which would be C. Okay, I got all kinds of unknowns. I don't know anything in here. But if we look at right triangle number 2, this one, and I took the sine of angle C, that would equal, in that right triangle, the opposite side, which is H, over the hypotenuse, which would be B. All right, both of these have that common side H. So what I'm going to do is solve each one of these for H. So I'm going to multiply both sides by C. Same thing on this one, multiply both sides by B. That gives me H equal to B times the sine of angle C. Now, both of these equations here equal H. It's the same segment, so these expressions are equal to each other. C times the sine of angle B equals B times the sine of angle C. All right, what I'm going to do is kind of a weird step, but just follow along. I'm going to divide both sides by BC. What happens is the B's cancel out here, and the C's cancel out on this side, giving us this nice clean proportion. Sine of angle B divided by side B equals the sine of angle C divided by side C. So if we go back to the original triangle, sine of angle B is being divided by its opposite side. Sine of angle C is being divided by its opposite side. And those fractions are equal to each other. All right, this is the law of sines. This is where it's coming from. Now, we could do the same thing to talk about angle A and side A just by drawing in a different altitude. Let's say we drew in this altitude here and called that H. We would do the same thing, and it would come together. What we're looking at here, this is the law of sines. Okay, that's the equation for it. It says the sine, when you have a generic triangle, okay, not a right triangle, just any old triangle. Okay, you take the sine of an angle divided by that angle's opposite side. It will equal the sine of another angle divided by its opposite side. There are 3 fractions here. You only use 2 at a time, okay? When you solve, you're going to be doing something like this. All right, but it doesn't matter which Which two of these three fractions you use, it doesn't matter. It just depends on the information that you have and are looking for. So let's do an example. Okay, it says solve the triangle. So that means we need to figure out all the angle measurements, which to get angle B, not a big deal. Angle B will be 180 minus 102 minus 17, which is 1961. Okay, so we now know all three angle measurements. What we're missing is side A and side B. So it's not a right triangle. I can't use my sine, cosine, or tangent ratios, but I do have the ability to use law of sines. I know the 102 degree angle, and I know its opposite side. So I'm definitely going to use that. I just figured out angle B, it's 61. I'm going to divide that by its opposite side. Okay, you notice how there's four parts. There's an angle, a second angle, a side, and a second side. Those are the four parts. You need to know three of those four things so that in this equation you've only got one variable so you can solve for it. All right, so we got a fraction equal to fraction, cross multiply. B times the sine of 102 equals 3 times the sine of 61. We are trying to solve for B, so I'm going to divide by the sine of 102. Remember, the trig function of an angle measurement is all one quantity. You don't take a number out of it, you don't put a number into it. So then we divide by the sine of 102. That gives us B. So now, let me get the calculator out. I'm going to make sure that it is in degree mode. It is. So I'm going to do 3 times the sine of 61 degrees, get an answer, and then that is going to be divided by, parenthesis, the sine of 102. Close that parenthesis for the angle, close the parenthesis for the divider, enter. There is my angle, or sorry, side B, 2 point. We'll just go to the hundreds, 2.68. Okay. Now, to find side A, what we've done before is just use Pythagorean theorem, but we don't have a right triangle. We can't do that. So, I'm going to do law of sines again. I still know angle 102 and its opposite side of 3. That will equal, now that we're looking for side A, I'm going to use angle A, which is 17 degrees over side A. And to solve it, exact same steps. I'm going to cross multiply. A times the sine of 102 will equal 3 times the sine of 17. Divide both sides by the sine of 102. Those cancel out, leave me with side A. So now I bring the calculator back up. It's still in degree mode. 3 times the sine of 17. Get that number. That is going to be divided by the sine of 102. Error. What did I do wrong? Sine of 17, enter, times 3, enter. I'm going to divide that by the quantity of sine 102. Close that parenthesis, close the divider. I think I just had a parenthesis mistake. All right, so side A. Well, kind of an unusual number, but that's what it is. 8, 9, 6. A little less than 1, which can make sense. The 102 degrees, that's the biggest angle by far. Its opposite side is the longest side, which is only 3. Side A is across from the smallest angle, 17 degrees, a tiny little angle compared to the 102, so the side is going to be a tiny little side. So, answer makes sense. All right, that's using the law of sines. That is it for this one. The next video deals with the law of cosines, just a different relationship. Please watch.